Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at the IGCSE paper, May-June 2019, paper 43, 2 hour and 30-minute paper. So let's see if we can get through it faster than that. I've got it worked out for us. And again, focus on how to set up the problem and how to think your way through the solving of the problem. Don't just focus on the final answer. Final answer you can find in the mark scheme, but you need to focus on how to do the problem. So here, number one, there's a train going from London to Marseille. Local time in Marseille is 1 hour ahead of the local time in London. Part A, work out the total journey time from London to Marseille. Give your answer in hours and minutes. So from London to Ashford, you just subtract 55 minus 19 is 36 minutes. From Lyon to Ashford, 1300 minus 755 is 5 hours and 5 minutes. And then between these two, Avignon and Lyon, you have 1 hour and 8 minutes. And from Marseille to Avignon, you have 38 minutes. You add all that up, you get 7 hours and 27 minutes. Remember, there's a 1 hour time difference. Marseille is 1 hour ahead. So you need to subtract that 1 hour, get 6 hours, 27 minutes is the time between the two. The distance from London to Ashford is 90 kilometers. They are at the same local time. Work out the average speed. So average speed is total distance divided by total time. So you have 90 kilometers, and notice it was 36 minutes. So 36 minutes divided by 60 minutes gives you 0.6 of an hour. 90 divided by 0.6 is 150 kilometers per hour. Moving on down here to part III. During the journey, the train takes 35 seconds to completely cross a bridge. The average speed of the train during this crossing is 90 kilometers per hour. The length of the train is 95 meters. Calculate the length in meters of this bridge. So notice what we have here. Here we have the train. This little box on the left is my highly artistic train, and it's 95 meters long. So this little line right here marks the front of the train and also the edge of the bridge. Now this train has to completely cross the bridge, meaning right here at the back of the train is the edge of the bridge. So that's represented by X, but we need the train to completely cross it. So that train has to cover the bridge plus 95 more meters, that is the length of the train itself, in order to get off the bridge. And so this mark right here, these two marks are what we're looking at, this length, and then we will subtract the train's length to get the actual length of the bridge. So remember, the train has to completely cross the bridge. It means the train has to get off of the bridge. So it's got to go that 95 meters extra. So it's traveling at 90 kilometers per hour. And notice it took 35 seconds. Now 35 over 3,600, I'm not sure why I wrote 7/12 here. That is not correct. I'm not sure exactly what I was thinking at this point. If you divide 35 by 5, you do get 7. But if you divide 3,600 by 5, you get 720. So I'm not sure why I have a 12 here. That's not correct, but I do put it correctly over here. So 90 kilometers per hour times the 7 over 720, which is what this should be 7 over 720 is 35 seconds over 3,600 seconds. That's an hour. So that crosses out our hour units and gives us kilometers. So 90 times 7 over 720 gives us 7/8 of a kilometer, 7 over 8 of a kilometer. And then we want to change that down to meters. See, it says calculate the length in meters of the bridge. So 1 kilometer is 1,000 meters times the 7/8 gives us 875 meters. That is from the front of the train coming onto the bridge to the front of the train after it has gotten off the bridge. 875 meters, and then we need to subtract the 95 meters length of the train so that we get the length of the bridge, and that's 780 meters. So make sure that you have your train going off the bridge and completely crossing the bridge when you do these problem types. So it's you have to mentally visualize that and solve for that. So you get 780 meters. Moving on to part B, the fares for the train journey are shown in the table. Adult standard fee is standard fare is 84, premier fare is 140, child fare is 60, and the premier fare is 96. So for the standard fare, write the ratio of the adult fare to the child fare. So the adult to the child for standard fare is 84 to 60, which reduces to 7/5. So it's a 7-to-5 ratio in its simplest form. For an adult, find the percentage increased in the cost from the standard fare to the premier fare. So we take the premier minus the standard on top, means there's a difference of $56, divided by the standard, that's kind of like the original. So 56 divided by 84 is a 0.667. Move the decimal over twice and you have a 66.7% increase from the standard fare to the premium fare. So you take the final minus the initial divided by the initial, change it into a decimal and then into a percent. For one journey from London to Marseille, the ratio of number of adults to children is 11 to 2. There were 220 adults in this total journey. So if you use the 11 to 2 ratio, notice 11 goes into 220 20 times the 2 will give you 40 children. So we use the 11 to 2 ratio with the 220 adults to figure out the 40 children. Okay, so 220 divided by 11 is 20, times 2 is 40. 220 adults to 40 children says all of the children and 70% of the adults paid the standard fare. The remaining adults paid the premier fare. So 70% of the 220 is 154. They pay the $84 price. So that's $12,936. The remaining, so 220 minus 154 is 66, pay the premier fare, that's 140, times 66 is $9,240. All the children pay the standard fare, which for children was $60. 40 times 60 is 2,400. Add all of those up and you get the total fares paid are $24,576. There were 3.08 times 10 to the 5th passengers that made this journey in 2018. This was a 12% decrease in the number of passengers that made the journey in 2017. Find out how many made it in 2017 and give it in standard form or scientific notation. So first of all, we have a percent decrease. Well, that percent decrease is from 100%. So 100 minus 12 means we have 88% of those who traveled in 2017 designated by the letter X. So 88% times X equals the 3.08 times 10 to the 5th. Divide that by 0.88 and you get the amount of people who traveled in 2017 was 3.5 times 10 to the 5th number of passengers. Number 2A, solve. This is a simple solving. Get your x's on one side, numbers on the other. So subtract 5x to both sides. Gives us a negative 17 equals 2x plus 3. Subtract 3 from both sides. Gives a negative 20 equals 2x. Divide by 2x equals negative 10. For B, find the integer values of n that satisfy this inequality. This is a joint inequality. We need to split it. The middle goes with both sides, so 4n greater than -7 over here, and 4n less than or equal to 8 on this side. So notice I just split it and I wrote it in the same order, so -7 less than 4n over here. Divide by 4, and I turned it around so the variable would be first. N is greater than a -7/4, which is a -1 3/4. And then on this side, 4n less than or equal to 8 divided by 4n is less than or equal to 2, meaning the 2 is included. This has to be greater than the -1 3/4. So the next integer above -1 3/4 would be -1, 0, 1, and 2, because the 2 is included over here. Those are the 4 integer values that fall within that inequality statement. Letter C, simplify. Here we have indice rules. So a to the third times a to the sixth. When you multiply like bases, you add exponents. So we get a to the ninth. Then here we have an exponent raised to an exponent. So we multiply. Don't forget this exponent on the outside of the parentheses distributes through the multiply. So that means the cube goes to the 5, the cube goes to the x, and the cube goes to the y squared, because those are all being multiplied and exponents distribute to multiply. So 5 cubed is 125. If you're working with numbers, you're going to go ahead and calculate it out. And then you have x cubed, and with the y, because you have an exponent raised to an exponent, you multiply and you get y to the 6th. So 125 x cubed y to the 6th. Now we have this division. Exponents also distribute to division. However, this outside exponent is negative. So that negative is going to flip your fraction over. So we have 64y cubed over 27x to the 12th raised to the positive 1/3 power. And again, exponents distribute to either multiply or divide. So 64th to the 1/3 power is 4. Y cubed times the cube times the 1/3 is just y to the 1 power, divided by 27 to the 1/3 power is 3, and x to the 12th multiplies the 1/3 and gives you 4. So you get 4y over 3x to the 4th power. So remember that 1/3 is same thing as cube root. So the 1/3 as an exponent is saying same thing as cube root. Cube root of 64 is 4. Cube root of 27 is 3. Moving on down here to these transformations. And here it says to, on the grid, draw the image of triangle A after being translated by vector -3/2. Remember, the top is x, the bottom is y. So here we take our A, we go back 3 up 2, -3/2. So from here, 1, 2, 3, up 2 is right there. From this one, we go 1, 2, 3, up 2, which is this one. And from this corner, 1, 2, 3, up 2 is this one. So this here is our translation of the object to the image with it's here in a column vector, where the x coordinate's on top and the y is on the bottom. That tells you how far to move it. Then for part II, triangle A after a flexion over the y equals x. Well, here's your y equals x. Remember, y equals x crosses the origin with a slope of up 1 over 1. So this dotted line is our y equals x. We're going to take this object and flip it over. All you have to do is take each of your vertices and go perpendicular to your line of reflection, and you have a half a rectangle here of this square right here, half of it. So you go half the other way. You go the same distance on both sides and you get this dot here. From over here, notice you're going 1, 2, and a half. So half, 1, 2 diagonals put you here. Over here, you're going to this place right here. So you have 2 diagonals to get to your line of symmetry. So you need to go 2 on the other side, which puts you right here. So this is your reflection over the y equals x. So just count from each vertex perpendicularly to your line of symmetry and go the same distance on the other side. Then letter B, describe fully the single transformation that maps A onto B. So we want A to come over here to B. If you notice, it looks like it's rotated like this, and it's going one sector over. So notice it's not going 2 sectors, it's just going 1 sector over. So that's a 90-degree, it's turning, so that's a rotation, 90 degrees counterclockwise or against the clock. You can say anti-clockwise. And you need a center of rotation. Well, your vertices need, for a 90-degree rotation, your vertices need to be at a 90-degree angle. So from this vertex to this vertex, you need to find out where that 90-degree is. So here's 1, 2, 3, 1, 2, 3. Here's your 90-degree. So our center of rotation is 1, -1, 1, -1. So make a 90-degree angle between your two corresponding vertices in order to find your center of rotation. Letter C, find the matrix. Okay, for the 2020 syllabus, you do not need to do matrices, but this is a scale factor. So all you have to do is take your identity matrix, which is 1, 0, 0, 1, and simply multiply it by the scale factor, which is -2. So you get -2, 0, 0, -2. It's quite easy, but you don't need that for the 2020 syllabus cycle. Then part II, calculate the determinant of the matrix in this one right here, part I. So the determinant, you subtract the cross multiplication. So multiply diagonal down, -2 times -2 is 4. Subtract the diagonal up, 0 times 0 is 0, 4 minus 0 is 4. 4 is the determinant. Moving on to number 4, we have a hemisphere. So that's 3-dimensional hemisphere with a radius 5.6, and there's also a cylinder with height of 10. Show that the volume of the bowl is 368 cubic centimeters. So here they give you the volume of a sphere. Remember, this is a half a sphere. So we put 1/2 because it's hemispherical times the volume of a full sphere, 4/3 pi r cubed. So the r is 5.6. And when you multiply this out, you get 367.8, says to the nearest centimeter. So 368 cubic centimeters. The tin is completely full of soup. That's this cylindrical thing here. It's referred to as a cylindrical tin. And when all the soup is poured into the empty bowl, 80% of the volume of the bowl is filled. So we take 0.8, that's 80% of our 367.8. Notice we go back to the unrounded figure. 0.8 times 367.8 gives us only 294.25 cubic centimeters are occupied by the soup in the bowl. And now it wants us to find the radius of the tin. Well, a cylinder is pi r squared, because that's the circle, pi r squared times the height. We know that the height is 10. So pi r squared times 10. And the volume of that, because it was full of soup, is 294.25 cubic centimeters, because that's what we got. It was 80% of the bowl. And so we divide by 10 pi, use your pi symbol on your calculator, and you get 9.366. And then square root. And of course, we want the positive root, not the negative root, because we're dealing with distance here. And we have 3.06 as the radius of the cylinder. Moving down here to our cone. has a radius of 1.75 and a height of 6. Calculate the total surface area. So the lateral surface area is pi r times L, and then of course your base is pi r squared. It's a circle, but the curved part is this pi r L, and so we need to find this L here. This 6 is the same as the height of the cone, so we can use Pythagorean theorem because this makes a right triangle here. 6 is the height, makes a 90 degree with the base. Do pi r Pythagorean theorem, a squared plus b squared equals c squared. So the lateral or slant height here, the slant height, which is called L, is 6.25. So the area of the curved part is pi RL, pi times 1.75 times 6.25, which is the L. And then the base is pi r squared. So it wants the total surface area of the cone. So it's 34.36 plus the 9.62 gives us 43.98, or you could round it off to 3 significant figures of 44.0. And actually, since this is maybe an actual, because we're using pi, it's probably not, this is probably rounded here, because pi is a irrational number. So to 3 significant figures, we have 44.0. Don't forget the 0 because it should be 3 significant figures. The 8 rounds this up to 44.0. So make sure you include the 0. I here has a cone where the top is cut off, and so you have a small cone over the as the top part of the bigger cone, and you have a 1.5 to 4.5, and I think this 1.5 I wrote in, so maybe we don't have that right away. The cone contains salt to a depth of 4.5 centimeters. So this bottom part of this big cone is filled with salt. So that leaves this little empty space, which is the small cone. And this is our same cone is up here. So 1.75 is our radius. And that's where the 6 comes from. So the 6, the total height, minus the 4.5 gives us the 1.5 height of the small cone. So the top layer of the salt forms a circle that is parallel to the base of the cone. In other words, the salt flattens out. Show that the volume of the salt inside the cone is 18.98 centimeters cubed. Okay, so here we have a 6, 6 to 1.5 is equal to 4. And we have our, so a ratio, and so this is going to be 1.75, which is the ratio of the big cone. 1.75 to 4 is 0.4375. So we're taking linear ratios this way. Okay, linear ratios this way. And so the ratio of the overall to the small, as far as height, is 4. So the ratio of the big radius to the overall gives us 0.4375 as the small radius. So we're working with ratios of heights to find ratios of radius here. Okay. Then, so the 6 divided by 1.5 gives us 4. And then the 1.75 to 4 gives us the 0.4375. So what we want to do is we want to take the volume of the big overall minus the volume of the small, and that will give us the volume of this bottom part. So the big volume minus the little one on top. So here is our volume of a cone, 1/3 pi r squared height, h. So 1/3 pi, the radius of this big cone is 1.75 squared, and then the height is 6, minus this little cone up here, 1/3 pi with a radius of 0.4375 squared, and the height is 1.5. And you subtract those and you get 18.939 to 1 decimal place is 18.9 centimeters cubed. So think through this up here, get in your mind, there's more than one way to do ratios. You can go small to big or small to, you can arrange those ratios in a couple of different ways. So find a way that helps you figure out the ratios. So you might have to think through this a little bit with the ratio part, but that's important in establishing the small cone versus the big cone. Then salt is removed from the cone at a constant rate of 200 millimeters cubed per second. Calculate the time taken for it to be completely emptied. Give your answer in seconds, correct to the nearest second. So we have a volume of 18.94. So I went to 4 significant figures so that our final answer is accurate, more accurate. So instead of using 18.9, I went 18.94 cubic centimeters. We want to change it to cubic millimeters. And so 1 centimeter is 10 millimeters. That's linear. We need to cube it to make it volume. And so 10 cubed is 1,000 times our 18.94 gives us 18,940 cubic millimeters. And it's going out at a rate of 1 second or 200 cubic millimeters per second. So divide that by 200 and you get 94.7 seconds. To the nearest second would take 95 seconds. So you got some unit issues and also linear to volume, your dimensions that you need to deal with as well. Here we get a diagram, shows the graph of y equals f of x, where f of x equals x squared minus 2 over x minus 2. They graphed it for you. You don't have to worry about how to graph that weird equation. They did it for you. And x cannot equal 0. Notice there is a break in the graph here, and that is because you can't divide by 0. There's a fraction in here, so 0 is not allowed in the solution set, so your graph does not cross the y-axis. Now it says use the graph to find f of 1. So that's function notation. You plug a 1 in to this and you calculate it out, you'll get a -3. So notice at 1, you are at -3, which is right here, -3. And then find f of -2. That means you plug in -2 first, and then the answer of that, you plug back in again. So this is like a composite function where you put -2 into the function, and then that answer goes into the function again. So you plug -2 in here. And when you plug it in the second time, you get 6.3. And it allows you between 6.2 and 6.4. So where was that's at -2. So -2, and up here, the function twice. So -2 gives you this value, and then you plug that one in and you get up to here somewhere. That's what you're doing. You can plug it in here, or you can look at, it's actually called graphical solutions. So you can also use the graph to find it. So f of 1, you're coming over here and you're doing it graphically. Notice it should match algebraically as well. You can use the two to Make sure you're doing it right, plug it in algebraically, and also look at your graph. So graphically, you're supposed to look at the -2. You find this value right here, which looks like 3. And then you plug in 3 and you get up here and you're estimating this point right here. That's your 6 point. I put 6.3 and it can be 6.2 to 6.4. On the grid opposite, draw a suitable tangent line to solve the equation. So notice here, the x squared is the same, the -2 over x is the same, but the -2 is different. So here we have x squared -2, suppose it was -2, so we need to add 5 to that. Add 5 to both sides so that the left-hand side is the same as our original, because that's what's already graphed. That means the other equation, our suitable straight line, is the y equals -3x plus 5. So we go up here to the plus 5. That's where it crosses the y-axis. And we go down 3 units and over 1. Notice the scale is different from the y-axis to the x-axis. Down 3, 1, 2, 3. Over 1 is all the way over here. Draw this line through, and it wants us to solve the equation, meaning the intersecting points, which is right here. It intersects this graph right there, and it intersects this graph right in here. And so you estimate those, and I have a -0.25 and 1.75, and it gives you the windows of acceptable values there for you. So graph your line carefully and look at the intersecting points. Now draw a suitable tangent and estimate the gradient at x equals -2. So we go over here to -2, and we come up here to our graph and we draw a tangent line. So what you want to do is you want to take a straight edge and you slide it up to the bottom of your curve so it's only touching at this -2 spot, and draw a straight line through it. So now this straight line is what we're going to find our slope of to estimate the slope of the curve at -2. And so when we do that, I pick 2 points on my line, just anywhere along this line, pick 2 points that you can figure out using the grid. And so the 2 points that I have are -3, 6.3, and 0, -3.6. And I do rise over run, or y2 minus y1 over x2 minus x1. Simplify it, and you end up with a -3.3. That is my slope from the line I drew. Obviously, when you put up your straight edge and you try to figure out where it's exactly touching, your straight edge might vary just a little bit. So they give you a window of opportunity here, anywhere between -2.5 to -4.5. Mine was -3.3, which is fine. So yours might be a little different from mine. It's okay, but try to get your straight edge to only touch the curve at one point right at the -2 location. Now it wants us to graph another one, this exponential here, 2 to the -x, all the way from -3 to +3. They've given you some of the values. You got to calculate 3 of them here. So if you put in a -3 with a negative in front, that means you have 3 cubed, which is 8. If you put in a -2, that means 2 to the +2, which is 4. And if you put in just a 2, the negative flips it over, so you have 1 over 2 squared, which is 1/4, which is the same thing as 0.25. So you plot these dots up here, and that is this exponential right here. Going this way, it's going downwards because the exponent is a negative on that. And then it says graph the y equals g of x. That's what we just did. This part here, these 3 points are for these 3 numbers that you got. Then your graph is another 3 points. Then it says use your graph to find the positive solution for f of x equals g of x. Well, this one is g of x, and this one is f of x. So that means where this one here crosses this one here. Now notice it crosses at a couple of places, but it wants the positive solution. This one back here would be the negative solution. It's negative on your x-axis. So the positive solution is this one right here. So it's almost to 2, 1 point something. And I put 1.85, and you can have anywhere between 1.8 and 1.9. So notice you do have to be quite accurate in your graphing in order to pick up that point, but it does want the positive solution. Moving on, we have a table here. Here's a boundaries, class boundaries. Wants you to calculate the mean. So we need to find the mid class of these boundaries. So between 20 and 30 is 25, between 30 and 35 is 32.5. Be careful calculating that. Add the two values up and divide by 2. So 35 plus 30 is 65, divide by 2 is 32.5. 35 plus 40 divided by 2 is 37.5. 40 plus 60 is 100, divided by 2 is 50. And you get 80 up here. These are your mid-class values. So you take the frequency times the mid-class values, you add them all up and divide by the total number, which is 120. And that gives you 40.458 to 3 significant figures is 40.5. Now to graph it, we need to find the frequency density. So frequency density, we need the class widths. Class width, 30 minus 20 is 10, 35 minus 30 is 5, 40 minus 35 is 5. So get the class widths, 100 minus 60 is 40. These are CW class widths. Frequency divided by class width is your frequency density. So 38 divided by 10 is 3.8. Notice they graphed, I think, part of it for you. It just wants you to complete the histogram. So notice the 3.8 was correct. Then you get 27 divided by 5 is 5.4. 21 divided by 5 is 4.2. 16 divided by 20 is 0.8. And 18 divided by 40 is 0.45. Notice the x-axis follows exactly along with the class boundaries, 20 to 30, 30 to 35. So your x-axis follows the class boundaries. Your y-axis is the frequency density, which is frequency divided by class width. Notice I did them all down here and show the values down here. Frequencies divided by class widths. And so these are the heights of your histogram bars. It is not a bar graph, it is a histogram. It's a continuous data. There's no gaps between the bars. Number 7, a straight line joins the points A and C, -2, -3, and 1, 9. Find the equation of the line AC in the form y equals mx plus c. So first we have to find the slope, change in y over change in x, y2 minus y1 over x2 minus x1 gives you 12/3, which is 4. That's our slope. For this particular one, I chose to use the point slope form. So y minus -3 equals 4 times x minus the -2. So I'm using point slope form here. Y minus a -3 is y plus 3 equals the slope times x minus the -2, which is x plus 2. Then I just move the 3 to the, distribute the 4, get 4x plus 8, subtract 3 to the other side, and that gives you your slope intercept form, y equals 4x plus 5, because that's what the form it wants, slope intercept form, y equals 4x plus 5. Now calculate the angle between AC and the x-axis. So that's between this line and the horizontal or the y-axis. So what you're going to do is slope is change in y over change in x, which in trigonometry or SOHCAHTOA happens to be opposite over adjacent. The y is your opposite, the x is your adjacent. So tangent is actually of the angle actually equals your slope. So the inverse tangent of 4, which is the slope, will give me the angle. And again, make sure your calculator is in degree mode, and you get 75.96. With Cambridge, with degrees, you only go to 1 decimal. The 6 rounds it up and makes it 76.0 degrees. Again, don't forget the 0.0 because you need 1 decimal for your degree marking. Letter C, A, B, C, D is a kite. So here we have A, B, C, D. Make sure when you're drawing a diagram, your letters go in order. A to B to C to D and back to A, where AC is the longer diagonal of the kite. B is the point 3.52. We already found AC in our line up here, 4x plus 5. So we see that the slope is already 4, meaning the slope of this line right here is the negative reciprocal because it's the diagonals of a kite are perpendicular. So the negative reciprocal is a negative 1/4. We plug that in. We take our point, 3.5 and 2, to find the C. And so we get y equals a negative 1/4 x plus 23/8. That is our equation for BD in slope-intercept form. Then the diagonals intersect at a negative 0.053. That's the midpoint, and it wants you to work out the coordinate for D. So these intersections, that's the midpoint halfway. So if you start with B at 3.52 and the midpoint is negative 0.53, that's where they intersect, then to find D, all we have to do is count over from 3.5 to negative 0.5 is a total distance of 4. We subtract 4 to get to negative 0.5. You subtract 4 again, and you get negative 4.5. From 2 to 3 is a plus 1. So then you plus 1 again, and you get to 4. So the coordinates of D is negative 4.5 and 4. Since M is the midpoint at where they intersect, you just have to go the same distance on the other side to get your coordinate for D. Moving on here to 8, we have probability. Angelo has a bag containing 3 white counters and X black counters. Takes 2 counters at random from the bag without replacement, meaning he doesn't put it back. Complete the following statement. Find the probability that Angelo takes 2 black counters. Well, the first one would be X, because there's X black, over a total of X plus 3, which is how many counters there are total. So the number of black over total. Now, once he takes that out, he doesn't put it back, meaning now for the second draw, there's 1 less black counter, and there's also 1 less total. So you subtract 1 from both, and that will be your probability of getting the next black or the second black counter, X minus 1 over X plus 2. The probability that he takes 2 black counters is 7/15. So this X over X plus 3 times the X minus 1 over X plus 2 equals 7/15. Show that we get this quadratic. Well, we need to multiply out all the denominators. We need to clear our fraction of all those denominators. So we're going to multiply everything by 15, an X plus 3, and an X plus 2. So on this first term, the X plus 3's cancel, and that gives us a 15. And here we have, when we cancel all this out, trying to follow what did I do here. Or, I guess what I did was actually, it looks like I cross multiplied more than canceling it out. So I showed it as canceling it out, but what I actually did was just cross multiplying here, since it is a multiplication. You can do it either way, but maybe it's a little easier to cross multiply. So here's the 7 times the X plus 3 and X plus 2 equals the 15 times the X and the X minus 1. So yeah, if you look at it as canceling out, yeah, this is not an add or subtract. So when we multiply this by over here, the X plus 3's and X plus 2's cancel out. giving us the 15 times x and x minus 1. That's right. And then when we multiply it on this side, the 15s cancel out and gives us 7 times the x plus 3 and x plus 2. Distribute through 15 times x squared minus x. That's multiplying these. Over here, distribute these two. You get x squared plus 5x plus 6. When you multiply these two together, your nose is 3x, your mouth is 2x. That gives you 5x. Distribute the 7 and the 15, and you get this. Combine everything onto one side. Notice I subtract everything over to the left to end up with a positive x squared, and you end up with 8x squared minus 50x minus 42 equals 0. Divide everything by 2, because you can simplify it down, and that's how you get your 4x squared minus 25x minus 21 equals 0. Solve by factorization. Then your factors of 4 are 1 and 4, 2 and 2. Your factors of 21 are 3 and 7 and 121. And to get a 25 by subtraction, your 4 times 7 is 28, minus 3 gives you 25. So you want a 4 and a 1 in the front, a 3 and the 7 in the back, with 3 times the 7 giving your negative 21, the 4 times your 1 giving your 4x squared. Your negative 28x minus your 3x gives you your negative 25x. Then when you solve these, you get x equals 7 and x equals a negative 3/4. There's your two solutions. Write down the number of black counters in the bag. So remember, this was coming all the way back. This was telling us the ratio or the probability of getting the two black counters. So now what we want to do, now that we solved for x, remember x represents our initial number of black counters. So we have two choices here. We can either have 7 or a negative. Obviously, you can't have a negative number of counters. So 7 is how many black counters there were to start with. So all of this algebra, don't forget that it's representing the probability statement that we had before and helping us to solve for how many black counters there were to begin with. Now, Esme has a bag with 5 green counters and 4 red counters. That's a total of 9 counters. She takes 3 counters at random from the bag without replacement. Work out the probability that the 3 counters are all the same color. So we have, they could either be all green or they could be all red. So if they were green, you would start off with 5 out of 9. Then if you don't replace it, that leaves you with 4 green out of 8. And then you don't replace that one, that leaves you with 3 out of 7. So this is if you got 3 green in a row. If you got 3 red in a row, because notice it just says the same color. So if it's red, it would be 4 out of 9, then 3 out of 8, and then 2 out of 7. And we're going to add these two different, the possibility of it being all green or the possibility of it being all red. So you get 5 42nds plus 1 21st equals 1 out of 6 probability of getting them all the same color. Coming down here to number 9, we have a triangle, right triangle, that is then broken up into 2 smaller triangles. So it says show that AC, A to C is 76.68. Notice this is 5 points, correct to 1 decimal place. So what we're going to have here, we're going to have to do a little bit of angle playing around here. The angle of elevation is 26. The angle for CD of C from D is 72. Okay, so that makes a straight line here. So this 72 makes a straight line. Supplemental, meaning that we have 108 degrees here, and your 3 angles have to add up to 3 angles have to add up to 180. So 180 minus the 108 and 26 gives you 46. And then also in here, you have 90 and a 72, and so 90 minus 72 gives you 18. So 46 and 18 gives you 64 degrees there. So once you have all of that, we want to find the side. We have this length with this side here, 58 with the 46. So since we have a length and an angle, we can do law of sines to figure out this one right here. So 58 over sine of 46, because we have a pair that is both a side and its corresponding angle. So we use the law of sines, equals AC over sine of 108. So just multiply the sine 108 to the other side to get AC by itself. Do all of this on your calculator. Again, make sure you're in degree mode, and you end up with 76.68 or 76.7 to 3 significant figures. So you had to do a little bit of angle figuring out first. What was important was really getting this 46 right here. You didn't really need all these other ones. The 72 helped you get the 108. The 108 and 26 gave you the 46. Because you have a pair, you can just use the smaller one. We don't really need this outer one for this particular part. Now down here, calculate BD, that's this little one. So sine of 64. So over here, now that we have the hypotenuse, we can get the opposites, because this total is 64. So opposite over hypotenuse. So sine of 64 is A to B over the hypotenuse 76.68. Again, use the non-rounded value. Then solve for AB, multiply the 76.68 to the other side, times sine of 64 gives you 68.92. Well, this DB is this little part here. So we have to subtract the 58 from this, and that gives us 10.9 right there. Now moving on to here, we get little triangle EFG has an area of 70 meters squared. E to F and F to G has E to F and F to G has a 1:2 ratio, where EFG has a 40 degrees. So I draw in here EFG with a 40-degree angle, ratio of 1:2. So we don't really know much about the side over here. Calculate EF. So EF says the area of the triangle is 70. Okay, the area of the triangle is 70. We know that the trigonometric area of a triangle is 1/2 AB sine C. So if the ratio is 1:2, then here's 1/2. A is our one value of X times B, the other adjacent side, two values of X, times sine of the angle in between. So we're using our area of a triangle because it gives us that value to find out these sides here. And it wants EF, which would be our X here. So we get the 1/2 cancels the 2. We get X squared, divide 70 by the sine of 40. Take the square root of, well, that gives you 108.9, then square root. Obviously, we want the positive value. So X, or this one part of the ratio here, or what I wrote as X, E to F is 10.4. A different triangle has the same area, PQR, and PQ and QR also has a 1:2 ratio, and PQ equals EF. So P to Q is equal to E to F, has the same ratio. Q to R, which probably goes out this other way, or Q to R, Find angle PQR. Okay, so notice it's a different triangle that also has the same area. So we're going to take our 180 degrees, because it's a different triangle, minus the 40, and notice it made the PQ equals EF. So it's the same kind of ratio thing here. So we want to take the 180, which is our straight line, minus the 40, gives us this angle over here, and we get 140 degrees. So remember, PQ equals EF, so it equals the 10.44, and it's a 1:2 ratio of QR. So we have 1/2 times 10.44, because our PQ equals EF, so it's the 10.44. And since it's a 1:2 ratio, it means the QR has 20.88 times sine of the 140, which is the other angle, equals 70. And we see that that does work. So we get the 140. You could have worked it backwards. We want the angle. I think I made a logical deduction here to get 140, and then I double checked it. If you wanted to set it up with it as a variable, you'd have 1/2, 10.44 because they're equal, 20.88 because of the 1:2 ratio, sine of C equals 70. 70 divided by these, and then inverse sine would have given you your 140 degrees. So instead of you trying to deduce this, I think it would be better for you to set this up as 1/2, 10.44, 20.88 sine of C, representing your angle PQR, or sine of PQR if you want, equals 70, because it says that it also has the area of 70, and then take 70 divided by this over here and inverse sine that answer to give you your 140 degrees. That would have probably have been the better way for you to set this one up. I kind of jumped to a conclusion and then tested my hypothesis to check that, make sure it worked. Here we have sequence. 19 minus 4 is 15, minus 4 is 11, minus 4 is 7. Come up with the next two terms of the sequence. So minus 4 is 3, minus 4 one more time is a -1. Find the nth term of the sequence. So here is our a to the n equals, and the first term is 19. So an equals a1 plus n minus 1 times d, where d is the difference. First term a1 is 19. The d, or difference, is a -4. Distribute the -4, you get -4n plus 4. Combine those, and you get a -4n plus 23. That is our nth term. Find the value of n when the nth term is a -65. So we set this equal to a -65. Subtract 23, we'll get -88 divided by -4, n equals 22. So 22 is the nth term. So I just set this equal to this over here. Another sequence has 2n squared plus 5n minus 15. This is a different sequence. Find the difference between the fourth and the fifth. So plug 5 in and you calculate it, you get 60. Plug 4 in, calculate it, you get 37. Subtract the 2 and you get 23 is the difference between those two. And there we are, racing through to the end of paper 43. Again, thank you for joining me on Quick Fix. I hope that helps you think your way through the problems, and hope to see you again next time.